to the Astro Imaging Channel. Tonight's show, Prism, an all-in-one imaging solution by Bob Sanis, who's in the room. But first, as always, we're going to go over our image of the week. And this was a great image. It's funny because I think that it's the first image that image of the week at least, that we looked at that I said, what is that? And I actually had to go to his description to figure out which object it was, because I'm pretty certain it's a southern object. But Jose Joaquin Perez Guy, this NGC 6744 in Pavo, great image. I do not have the details. I invited him to the room. If you're out there, you do have an invite. You can probably get into this hangout if you're within. If you come in at the end of the session, we'll give you some time to talk about it. But it's a great image. I want to thank you for contributing and remind all you guys that you can just post your images in that thread, which will be reshared tonight. And then you'll be put into consideration for our image of the week. And that's only for a little while longer, because we have been working on our website, and it's coming along well. And I expect you'll be seeing it soon. And it'll be a great way to contribute your images and just see all the image of the weeks in one spot rather than navigating the Google. But thank you, Jose, for contributing. And guys, contribute. And we will check them all out. But for right now, I'm going to hand it right over to Bob. Bob, you right there?
I'm here.
All right. The room goes to you.
Thanks very much, Adam, and appreciate the opportunity to chat with you about Prism tonight. Got a little bit of a cold, so forgive me if I sneeze or wheeze or whatever. Why don't we start by taking a look at the Prism Pro screen that we've got up there and kind of give you the high-level overview of the functionality within Prism. If we were to go through every function and demo it, we'd probably be here for 5 or 6 hours, so we won't do that. But you can see under File, we have the whole usual range of opening images, saving images, exporting it in different formats, and so forth, as well as some scripting functions down at the bottom there. The Edit menu gives you the ability of looking at the image headers, the FITS headers, and opening them up and making changes. Also the Undo Redo, and you've got the usual kind of functionality in terms of mirroring and translation, resampling, binning, all that kind of good stuff. SkyChart we'll come back to and go through some more detail. This is the planetarium portion of Prism that gives you access to a large number of catalogs, both deep sky and star catalogs. The image display function controls how we display images on the screen. So we have things like contrast, luminosity, magnifiers, grids, zooming in, zooming out, palettes, and all the other kind of stuff that you need, as well as the ability of printing off images. Processing is a fairly all-encompassing function, and probably what we should do is we should come back to it, but just in a nutshell, this is where you do the calibration, you fix up the images in terms of gradients and cosmetics, you can do all your filtering and other type of functions, correcting for optical distortion, digital development processing, deconvolution, fast Fourier transforms, and so forth. Stacking is what you'd expect, the ability of normalizing your means and your backgrounds, and the various stack operations, registration, and of course drizzle stacking if you want to try to increase your resolution. Moving object stack is particularly geared towards looking at things like comets and asteroids. Color imaging is the ability of combining your monochrome images to create color images, as well as splitting color planes, converting to black and white, all those other kind of functions you need. Analysis gives you the ability of looking in detail at your images, including statistics, centroiding, graphs, histograms, plate solving, photometry, asteroid, comet detection, optical alignment type functions, ability of checking the quality of your images, and stellar sharpness. The observatory is where we actually link up to equipment and we control your equipment. One of the unique qualities that Prism has is the ability of controlling more than one camera at a time. The system that I have in Chile, which if we have time we can switch over to a little bit later, is set up so I have a 14.5-inch Newtonian, and then on top of it I have piggybacked a Astrophysics 130. Both of them have STL cameras on them, and what I like to be able to do is to be able to look at both of those systems simultaneously. So I can be imaging in high resolution through the Newtonian while I'm doing wide field shots with the Astrophysics. And so in this section, this is where we link up to our cameras, we link up to all our telescope hardware, control the focusers, filter wheels, your dome, shelter control, rotators, link into a GPS if you want to get precision time data as well as location, control your observatory switches for power and so forth. Autofocus, of course, is built into Prism, so we have fully automatic focus functions, the ability of capturing your calibration images, telescope status and controls. There's also a pointing model function that's built into Prism, so if you've got a fixed observatory and you want to get a good pointing model, Prism will do that for you. And in telescope tools, there's the ability of doing periodic error measurements, Peck analysis, polar alignment, finding your telescope position as well as finding it anywhere in the sky. Automatic observations is, if you're familiar with tools like ACP or CCD Autopilot, basically this is our version of that and allows you to do full automatic startup imaging, shutdown functions while you're sleeping. And the object list gives you the ability of setting up objects. The settings basically allow you to set up your hardware, your software, so your file types, location, as well as your paths for star catalogs and so forth. And plate solving parameters as well. And of course there's a help function. There's about a 536-page manual for Prism that gets you started, as well as on the forum there's the ability to do questions, and on the website we also have some videos, and we'll be adding a lot more videos because often that's the best way to learn is by actually looking at a video. So that is, in a nutshell, what Prism is all about. The whole idea here is to have a fully integrated type of approach. Previously, what I was using 5 or 6 different programs that be linked together, and they work quite well. The complication was that every now and then I'd update a program, or a program seemed to update itself, and then the whole thing would suddenly stop plate solving or stop doing something, which I found very frustrating. So when I discovered Prism and its ability to be fully integrated and not rely on those kind of variables, I was quite excited by it. Prism itself has been around for about 20 years. It started out as a French program and eventually developed an English version, but the English version still had a lot of French in it, and I don't know how your French is, but mine is not very good. So I wasn't too thrilled with that, but we got together with the original developer and we redesigned the user interface to simplify it, because it had been designed in many cases to support professional observatories. So a lot of the functions that were in there were just way too advanced and unnecessary for the kind of work that we do. And at the same time, we wanted to make sure that we had proper English documentation and we had support that would enable people to use Prism effectively. And so that's kind of the genesis of where Prism came from. But as I say, there's about 1,000 people using the earlier versions of Prism, which were available in various languages. So with that, let me just move ahead here, and you can see we've got one image on the screen here. The icons up above give you quick access to opening an image, saving it, browsing through images. Image info is a very useful thing where you can immediately get information on the image you've got up there, size, the pixel types, when it was taken, and so forth. Exposure information about the scope that was used, focal lengths, again, detail on the CCD, image history as to what was done to the particular image, plate solving and photometry data as to whether or not it's been plate solved, what was the sky, the sun's elevation, how high was it pointing, how much air was it shooting through, and where was the location of the site that was taken from. These images that I'll be showing you today were all taken from my remote observatory down in the Atacama Desert, so we'll have a chance to look at a few of those. And there's options for picking up your comments, as well as if you have a weather station, it would automatically capture all the data associated with the weather data at the time of the image capture. Going across here, we have the ability of undoing as well as redoing. So if we do a function on the image, so for example, if I just rotate that image like so, I can undo it just as easily by hitting the undo function, or the redo function will redo it again. The luminosity and contrast function is located here, and if I just grab the center of this bar, I can kind of move my overall relationship of the luminosity of the image. And of course, I can just pick up either one of these cut pointers here to select exactly how I want to have the image operate and look.
Bob, can I interrupt you for 1 sec?
Sure.
Two things. First, for our viewers out there, we have a Q&A app. If you're not familiar with our format, if you click up on the top right of your screen, it lets you ask questions, and I will call them right out to Bob. As well, Alex from inside the room has a question in regards to, we see FITS files, but does it work with one-shot color CCDs? Does it work with DSLRs?
Yeah, it also will work with DSLRs, and probably, I'm not a big DSLR user, I have to confess. One of the functions we have here is to turn a raw bare image into a color image. You can also turn it into a monochrome image. So there is functionality. We are going to be bringing out a version which is going to be geared towards DSLR users, and that'll be coming out in the new year. It'll be a lower price version than this one. This version retails for $5.99 and will be sold when it goes on sale next week for $4.99 introductory special price. And so we'll have a new version for the DSLR users, which will be coming out next year. So this version is designed really for more CCD camera support, but it does have DSLR functionality built into it as well.
That's great.
All right, so let's see, we'll just continue along here real quick. We can zoom in, we can zoom out. We also have the ability of adding a magnifier to the image, excuse me, with a different zoom factor as well, so we can examine the image in detail. And let's see, we can also set up our parameters. That's the telescope setup. This allows us to link into our camera, number 1, number 2, and number 3. So you could have 2 imaging cameras, for example, and an auto-guider camera, all connected up at the same time and be imaging through two cameras simultaneously. This actually enables the telescope filter wheel setup, I should say connection. So for example, let's just show you what that looks like here. That's the demo CCD camera, and the usual kind of controls where we can set the exposure time, we can set it up to loop, how many loops or an infinite loop and a delay between them, the binning factor. We can also set up a sequence. If we hit this button, we're taken to a different page, which allows us to set up a sequence, and typically use that for a quick and dirty type of sequence that you want to grab, like a RGB or an LRGB type sequence. Down at the bottom here, you have the ability of setting up your file names, your directory where you want to put the data. It'll automatically create a folder for you based on the date. Windowing, of course, is available to set the window full frame, half frame, or whatever you want to do. The camera can also be controlled in terms of controlling the shutter. So if you wanted to force a dark frame, you could, although obviously there's the mechanisms to capture your dark frames that I showed you earlier. CCD temperature is set here, which gives you cooling power. It also gives you graphs of your temperature and your cooling power, so you can monitor that if you wish. Here you can set up rotations and mirroring on the particular images, as well as creating a grid. Guiding is very straightforward. If you want to use this camera for guiding, you go through a simple calibration process, which I'm sure you're probably familiar with, where you select a star or have the guide star selected automatically. And there's also support for both AO as well as for the new Sharp Lock that you're going to be hearing about, I believe, next week. There's some information in terms of how fast the data is read out, as well as being able to grab statistics. And you can actually put in some log information if you want, as well as set up the header. So there's quite a bit of capability built into the camera type capability, and we'll just get rid of that. And
Can I ask a question?
Sure.
Dual camera support. Do you support? Do you have dithering, and is that supported with dual cameras?
Right now, the dual camera support is not set up with dithering, so it's more opportunistic support is the way I would describe it. The advanced version, which will be coming out next year, will have full support, so the cameras will be controlled sequentially, so the dithering will be accounted for. And I may not be explaining that as clearly as I could, but suffice to say that right now what I can do is I can start an exposure running on camera number 1, and I can start one on number 2 right after it manually. With the advanced version coming out next year, it will do that all automatically for you, so that it's smart enough to know exactly when to start that next camera running.
Okay, great. Thank you.
This is showing you how you link up the hardware, and it basically gives you a status. It says that we were successful. It tells us what telescope we're using. It tells us the guiding device, our monitor, if we had a cloud monitor, the focuser, filter wheels, shelter control, weather station, and the derotator. So you have all that information. And oh, we got a violation for something there. It doesn't really like the simulators as much as some other things, but nonetheless, it gives you a flavor here for what you're going to see. So you can see that it basically has the dome position information if you have a dome. Down in Chile, I'm fortunate just to have a clamshell dome, so I don't have to worry about slits and such, but in my backyard observatory, that's what I have. And it gives you the status of where the telescope is located and pointing and so forth. So it gives you a little bit of a feel, and when we get down to Chile, you'll get a better feel for how the equipment all lines up. This is a centroiding function, which is a handy thing to do if you just want to take a look at a particular star. And we'll just grab this guy, and it gives you information as to exactly what the full width half max is, center location, all the details on it, the flux, signal to noise ratio, and so forth. So very handy for you to be able to monitor your image quality. This allows you to quickly create a new sky chart. We'll come back to the sky chart thing in a few minutes. Software setup sets up those parameters, and there's lots of flexibility there. This is the ability of creating your master frames, calibration of images. Log transform is a very handy function. You know, I never used to use log transform until I started using Prism. I also always used to run a DDP real quick on my image to kind of see the extent of nebulosity and so forth. But I find that this actually works quite well, as long as you're not too aggressive on the strength of the processing, but it gives you a quick look to see the extent of the nebulosity in the image. And of course, you can undo it. One thing I didn't mention on the undo function is this thing operates with an unlimited number of undos, so you can go and do a whole bunch of steps, and if you goof up the last one, you can just go back as many steps as you need to in order to get back to where you were. Global statistics give you a quick snapshot of what your image data looks like, and we'll get rid of that. And then, of course, you have the ability up here of cropping an image, so you can quickly just pick up the area that's of interest. And let's see, this is the DDP function, and we can talk about that later. And finally, automatic observations. And this really gives you the form, which allows you to set up all your objects. So you can add an object, delete objects. You can use the list of objects that's been previously created. And we can just real simply add an object here. So let's say, for example, we want to look at NGC, I don't know, 300. We look up the coordinates. We'll say the exposure times 100 seconds. Binning factor is fine. We just get one image. We'll use filter number 1. And we're not going to bother with auto-guiding. We'll say we'll focus on the object. And so it creates that entry for you. You can duplicate these entries if you want real quick, or you can create an LRGB type of image, and that's the way you do it. So you create your targets, you tell it what you want to do in the way of focusing. For example, often I'll do focusing every 30 or 40 minutes just because of temperature changes in the desert that necessitate that. You also tell it what you want to do with your dome or shelter. Usually what you have is some sort of an executive program which is going to run to open or close your system, and that's what we do there. On the image grab options, you have the ability of specifying the folder and how you want to name them. You can also save regions if you want to be able to check it later, set up the auto-guiding parameters that you have. Telescope, you've got controls to avoid the moon, don't slew below a certain level, etc. Flats recording information if you want to do evening or morning flats. If you've got a specific startup thing that you want to do, you can run that here as well as when you want to end the whole session and warm up the camera. You can even send emails off to indicate that things have gone well, or if there's been an error. And then finally, of course, the execute button, which actually says go ahead and run the whole thing.
Can I ask another question? You said avoid the moon.
Yes.
If you have a number of targets in there, will it skip a target that's within a certain...
Yeah, it's got a heuristic in it, so it's quite intelligent. It'll actually, unless you specify that you want to run it in a certain sequence, and that's one of the flags that you could check off there, it will basically pick the object which is highest in the sky and farthest from the moon to start with, kind of thing. It'll always do the human thing, if you will, to try to give you the best image that you possibly can.
Great. Yeah, that's very convenient.
Yeah, I like that feature. I don't have to think too much, so that's a good thing. So with that, maybe what we can do is we can just take a quick peek here. I don't think there's a lot in file that I can really amplify on unless someone's got a question on it. We do have one capability that I should mention, and that is you'll see here two types of formats. We have the normal fits, but we also have something called CPA, if I can find it here somewhere. Fits it. I was looking at it earlier, but anyway, it is about half the size of a FITS file. It's a lossless compression, so it's a great way to transmit images back and forth from a remote site. If you're involved in a remote site at all, it's a very convenient capability to have. Let's see, importing images, you can bring in just about anything. One of the neat features as well is being able to get a DSS image of the target you're looking at so that you can see how a professional scope imaged it and you can compare that to what you're getting. Some batch conversion type functions, the ability of creating an AVI file out of a bunch of FITS images, which is great if you've got a comet or some object moving through the field, asteroid. The scripting functions are covered by a separate manual, which is still in preparation, but basically you can do just about anything on Earth. One of the users has created a script which is about 1,200 lines long. The nice thing about the scripting language is it's simpler than BASIC. So if you can program in BASIC, you won't have any problem with the scripting language. On the edit functions, nothing really exciting there other than the normal functionality you would expect to be able to do just about anything you want to do to the image. Let's take a look at sky charts and give you a feel for what that's all about. This is a typical image where we're looking at a field, and let me just go to something which might be somewhat recognizable. So, and you don't have to put in NGC. We just use N as an abbreviation. And the image, the system that I'm looking at right now is this is what I'm imaging right now down in Chile is NGC 1365. And so we have a frame around there which shows my field of view. It also shows all the other NGC objects. And the way we set this up is we have a whole bunch of settings that allow us to select what are the deep sky catalogs we want to use. Do we want to see the Milky Way or not? What are the star catalogs we want to use? These are all the available star catalogs. Of course, GSC, the U.S. Naval Observatory, CAC, the Nomad, or you can even pick up some internet catalogs as well. The ability of throwing up asteroids and comets. We have the comet data set here that we can throw up and we can select what we want to display. For asteroids, we can also specify the asteroid database we want to use and throw those up on the screen. CCD file, I should fix this because this is actually should be 90 degrees, not 0. And that's the camera that we're using, and that's the correct focal length for it. So we'll set that as default. And on general display, you have the option here of showing your constellations, grids. You also have the ability of having a terrestrial chart. So you can have a terrestrial chart, or you can have the normal RA deck alignment, which is what I normally use here. So that's what we're set up. And you can also put in horizons, as you would expect.
Bob, are those catalogs downloaded to your computer, or do you need to have internet access?
They are. Some of them are. Let's just take a look at. For these, I have all on my computer. The GSE, all this stuff I have on my computer. So I, recommend those to be local. If you don't have them on your computer, you can always just access the Nomad catalog. PPMXL is quite a good catalog, and it's accessible by the internet. For the deep sky stuff, this stuff is all on the built into Prism itself. When we ship Prism, we also give you the GSC ACT catalog. So this is included. It's built into Prism itself because it's just such a essential tool to have. You have the ability of sorting because you can get a tremendous amount of data this way, and so you have the ability of specifying things, for example, over a magnitude range or an object size. Often what you want to do is you want to be able to specify, gee, I'd like to look at galaxies tonight, but I want to have objects of a certain size, so forget about the really faint stuff, forget about the really tiny galaxies, give me some larger ones, and that's what it can certainly do for you. Let's see, date and place, of course, allow you to specify where you are, and you can also set up animations by specifying the increments and how far you want to go. So a lot of different capabilities there, and we will be doing a special video on sky charts, which will probably take 3 or 4 separate videos. I'm a believer that any video longer than about 8 minutes is too long, and people tend to lose interest after a while, so we try to keep them in chunks and make them as easy to digest as possible.
We got 2 more questions. Is star matching, or I'm guessing plate solving, built in, or do you need a separate catalog?
No, plate solving would use the GSC catalog. I use the UCAC4 catalog normally, or the U.S. Naval Observatory A2 catalog, which are available in the public domain.
Okay, and Eric's asking, can you rotate your field of view to help select guide stars, and are the stars labeled?
Are the stars labeled? You can see here the GSC stars pop up, so we can specify. I mean, I can go click on it. It'll tell me the magnitude of the star, so I know that that's a 9th magnitude star if I'm looking for a guide star. Can I grab that and rotate it? No, I don't think so. But what I can do is I can specify here the rotation angle on this, unless you've got a rotator, which would be linked into the system, and then that would be able to rotate the individual display. But here, as I mentioned, I should have this set up for 90 degrees, which is the way it's set up on the system in Chile. So let me just click OK, and there, she rotated back. So I could specify any angle I wanted, and that would then line up so I could see whether or not I have guide stars. I have to confess that in terms of auto guiding, I stopped auto guiding with the new mount I bought. So I have one of those direct drive mounts down there in Chile, and it's really hard to go back to guiding. But so we're not really doing much guiding these days. But I did use Prism previously with another mount, and that was guided through an ST402 and off-axis guider, and it worked like a charm. Didn't have any problems. So sky chart wise, that's the way you set up all the different options. This icon gives you the view, an overall view of the sky, so you get a feel for where you are. So there's our target, NGC 1365. There's where the zenith is. And if I want to move the display around, I just click and drag a bit, and I can move the overall display up or down or whatever I want to do. And of course, I can use the mouse wheel here to scroll in or out, so I can zoom right into any particular target area. And if I want to look for a particular object like that, I can just go like so. It finds the object. I can then go over there, and then using a right click, I can center the object. And then if I want, I can also change the zoom factor. So I can just zoom right on into the target area and see what I've got. Right-clicking also gives you a whole bunch of other stuff. Somebody asked on our forum, can I just look at the horizon? Yeah, you just go here, click on north, south, east, west, whatever you want to do at the zenith. You can slew the telescope. If we had a telescope live to the system, we'd be able to slew it, sync it. You can data connect by merging images onto the sky map, centering it, and so forth. You can add this particular object to that list of objects, which is the list that we want to observe. We can send the RA index to the clipboard, and without going through a lot of stuff, this is the way you download a DSS image to compare and see what you got. You can go out to the web and go to the Strasbourg data center and get what the professionals would give you, which is a whole lot of stuff in terms of what's available there. You can copy it and so forth. So again, a lot of different options and capability associated with the map. Up here we have the ability of erasing any identification labels we've thrown up there. Print screen works remarkably well. Some programs don't really do a great job of printing the screen. This one does a pretty good job, I think. You can modify the sky star size, rather than star size, and you can also flip back to the previous view that you had. If you want to go to a set of coordinates, you just click that, put in the RA and DEC or alpha azimuth, and you can go directly to a set of coordinates. Refreshing the chart. This starts the animation. As I mentioned, we can fully animate the chart. There's also an ephemeris table which allows you to take a look at, well, for example, here the moon and the sun are quite often what I'll look at to see how is the moon going to interfere with my observations based on date, and it gives you a detailed ephemeris, and you can do that for the planets as well. Solar system view just kind of shows you where the planets are within the solar system, which is kind of handy from an overall perspective. And this allows us to center the sky chart on the current telescope position, switch between alta-azimuth or equatorial mode. This is the mode that the mouse is operating in, and this is the normal mode we operate in, which is basically this identification mode and the ability of moving across the chart like that by moving it with a click and a drag motion. We also have the ability of going in and just zooming. If I want to just zoom in on that region, it'll do it for me. If I want to measure distances, I can measure the distance between a couple of different stars to see exactly how far apart they are. But the normal mode we operate in is the mode that we've indicated there. And let's get rid of the sky chart and image display. I think we probably could spend a lot of time on that, but I'd rather spend some time on a couple of features which I think are important, because I don't want to, as I say, I could talk for a long time, but I think I would bore you to death here. Image series calibration and stacking is a really powerful feature of Prism. So for example here, if I select the images I want, and there's that CPA format, by the way, that we were looking for earlier. That shows you it's about half the size, a little less than half the size of a FITS image, lossless compression. So that's included. So I'm going to just pick up 3 images here and select those. I've already created my master files and got a master bias and dark, and we're not going to bother with the flat operation because I don't have a current flat right now. Cosmetically, we're going to get rid of any extreme hot pixels, as well as we'll try to do some deblooming of these ugly stars. This is obviously a science camera, and it's used for occultations and asteroid periods and stuff like that, so it's not really geared towards pretty pictures. This is where you can calibrate your color image by selecting the Bayer matrix and do some conversions. You select image registration here, and we'll just go ahead and do the normal. Sorry, this is the full width half max criteria page where we can select what range of full width half maxes are acceptable. We also have image registration options here and our stacking options. And typically I use median stack, although sigma kappa gives a nice result as well. And once we press the button, away she goes, and it will basically do the full calibration except for the flat, since we don't have a flat. And when it's done, it'll come back, give us a full summary, and then tell us here's the result image, which we could then open up. And lo and behold, oops, here, let me just go up there, and you can see that the blooming is all gone, the dark pixels or bright pixels are all gone, and we have a reasonably nice calibrated image. So that's how that function works. You've got the ability of creating a flat from images, which I find quite handy, and I actually created a synthetic flat from that group of images, and it actually worked quite well. You can also remove sky background. You can do cosmetic corrections with columns and blooming and so forth. You've got the usual image math functions and ability of adding a constant or multiplying. Noise, you can add it if you need it, although usually it's just the reverse. We want to filter out noise. You can even write programs and create a plugin which does specific functions. Correcting for optical distortion doesn't correct for coma or astigmatism, just for barrel distortion or pincushion distortion. So if you're using a telephoto lens or a really short focal length instrument, this is a very handy feature. And of course the nonlinear processing with DDP, unsharp, decon. We also do all the wavelet processing. If you've done registrax, planetary type work, which I did a few years ago, the wavelet processing is very powerful. And you do an FFT on your images, which is really cool to look at your bias frames, and you can kind of learn how well your camera manufacturer has created the electronics in your camera and the ability of processing AVIs. Stacking, as I mentioned, we've got all the normal stacking type functions, color imaging. It's easy to throw the different monochrome images together. Statistics, we showed a little bit of in centroiding. Graphing gives you the ability of doing all the different types of graphs, histograms. Plate solving is quite a powerful function as well. And we can just real quickly just open up, oh, this is a calibrated image, so we can do a plate solve on this one. And we already pick up the target information from the mount. That was stored in here. We've got our pixel size, we've got our catalog, and these are all default values. I'm a great believer that default values should normally work. And fortunately this time it did. So there's a plate solve, and it shows us the image center coordinates as well as some coordinates and the residuals associated with that image. Whenever you get an image like this, what we can do is we just go up to image display and refresh the image, and it gets rid of all the nomenclature. Under photometry, we can do an automatic calibration on this image, and again we've got the basic data, and we just kind of turn it loose and let it go and extract the stars, which it has, and it then shows us the magnitude of all the different stars that were selected on that initial run, which was 60 stars. But we can do a little bit more than that. We can refresh the image. Oops, let me get rid of that, and then we'll refresh the image. Oh, we got that still out there. Okay, refresh the image again, and now we can go and do analysis, photometry, and here we'll actually go through and find every star in the image and do a magnitude search on that. And you might ask, why are you doing that? Well, there's a reason. If you go down to the bottom, one of the things it does is it shows you the sky magnitude, and it gives you a reading. So if you've ever wondered, how good is my sky tonight? Well, the night this was taken, the equivalent magnitude per arc second squared was 20.77. So instead of going out and buying one of those meters for $200, which are made just down the road from me, you can actually use Prism to give you that calculation. And of course, it also gives you a breakdown of all the stars that it found. And one of the things that's really useful is this one, which shows you the relationship between signal to noise ratio and magnitude. So you can see that with this particular image, we're basically getting up just over 21st magnitude, and safely we're getting well above 20th magnitude on this particular image. And once again, we can just get rid of that. Oops, we don't.
One more question, and that feature, my jaw kind of dropped. That's pretty cool. But one question that came in before that: is there a method for white balance calibration, G2V calibration, or anything like that? A built-in method?
You know, the answer is no. I know that I've used other programs where they've offered that kind of a calibration type function built in, and I don't think we have that. I'd have to ask Cyril to find out if it's buried somewhere that I've just missed, but probably not is my answer.
Okay, I think with G2V you can do the manual way from like prior data too, where you're actually changing your exposure length as opposed to scaling the individual exposures. I think. I'm not a G2V guy myself.
Yeah, no, I'm not either, so I'm not really the best person to answer that one.
All right.
Let me quickly show you the how we go about searching for asteroids. So these are 4 images that were taken with that system down in Chile, and we've set up the search parameters. Because we have 4 images, we can go down to as low as about 2.2 signal to noise ratio, and give that a try. We specify some parameters here, but again, I'm a great believer in using defaults, and the catalog we're going to use for the resolving. And this is just the image header information. If you're an asteroid guy like me, then you have a code and you have a header that you want to send off to the MPC people. And we turn it loose, and away she goes. And it will scan through and basically solve all the images and start looking for candidates of potential objects within those images. And then it'll display, and hopefully this is coming through okay, but you can see the target that is displayed within that circle, and then you have the option of selecting whether it's just some hot pixels moving around or whether it's actually a valid image. That one's valid, and that's a winner. Yep, yep, yep. And all of these so far are all valid. And then it gives you a report which shows you the speed over the ecliptic as well as the speed of the asteroids. And this is useful just to determine whether or not you found a near-Earth object that you want to report specifically. The asteroid search data gives you a lot of information. And we can show you, this is the normal header that you'd send off to the MPC, and by clicking on the clipboard function here, you can copy it and basically just paste it on the email you're sending off. And you can see we're getting down to about 20th magnitude. And I actually checked this with MPC, and sure enough, that asteroid is 20.1. So that magnitude calculation we did a little earlier was correct. I think at this point, if we still have time, Adam, what I'd propose to do is to switch over to the Chile system and actually show you the thing running down there in Chile. I don't know what, I've been talking probably too long here, but let me know what you
think. Go right ahead. We'd like to see it.
Okay, so if we can kill that, and we can go to, let's see, I guess I need to switch the screen share, eh?
Yeah, either Team Viewer or that, what was it, Screen 1? I think it was Team Viewer. I think Team Viewer will work.
Okay, let's see if we can, here we go. Okay, did that work okay?
Let's see, I have a blank screen right now, so we will see. Give me a second. I don't know, I think it's staying blank.
No, it appeared on my end. I am seeing Prism.
Okay, it's just a delay on my end, yeah.
Then so you see a nice little galaxy on the left-hand side?
Are you guys seeing it? Because I'm still not seeing it.
I got black.
I got nothing. The galaxy to the side.
Yeah, I'm seeing it, Adam.
Okay.
I'm not. It's blank here.
And its resolution is very high, so it might take a little while to download initially.
Yeah, it is. You know, one thing with Prism, I have to tell you, is that the more monitor space you have, the more you want, because there's a lot going on the screen. So I normally run HD or higher if possible. So that's.
Yeah, are you full screen right now, or are you sharing just the Team Viewer?
I'm just sharing the Team Viewer right now. Do you want me to try to go to full screen?
Try full screen for my benefit, because I still can't see it, and I'm afraid that you probably see what I see.
We went to full screen, and we'll select it again.
There we go.
You got it?
Yes.
It's good now.
Okay. So what's going on down in Chile is basically we've got the telescope tracking, and it's running a sequence of images, or at least it was. Let's just see here. We can start it up again. It gives you a warning basically saying, do you want to auto-record and have an exposure loop running at the same time? And the answer is yes, we want to record, and we want to just loop it through. And so over on the camera side, you can see that it's got countdown running in terms of how many more seconds we have to go on the next frame. We've got the camera running at minus 30 degrees with 62% cooling. And what else can I tell you here? The focuser basically gives us the current position of the focus. Telescope status is really a handy thing to have because it shows us where in the sky the scope is pointing. And you can see it's roughly at that 45, 50 degree range in the southeast right now. A key parameter here is the meridian angle. So we know that in an hour and 42 minutes it's going to hit the meridian and it will do a flip if we're running in automatic observation mode. If we're running just in this sequential mode, which I'm running in right now, it will actually stop at that point. It will not automatically do the flip. So it's your choice as to how you want to run it. This image was previously auto-focused using Prism and then auto-centered using Prism as well, where I did a plate solve on the image. And that's basically how it's operating. The focuser, of course, can be run in temperature compensated mode, or it can be run in a manual kind of mode. And what I should show you is, since we're over here, is so the focusing actions you have are manual, which is just the normal kind of thing where it puts big numbers up on the screen, and you can turn the knob, or you can use your focus control to focus. It has spectral line, which is something if you've got a spectrograph. Automatic is the normal focus mode where you select a star on the image, or direct autofocus means you just tell it, I want to go focus on a star somewhere between 8 and 12 magnitude. Go find one within a radius of a couple of degrees. It goes, finds it, does the focus, and then it will go back to where you were. As I mentioned, you have the ability of capturing your biased dark and flats, as well as it'll automatically select a time for the flat fields. Telescope status just puts up that display that we saw over on the far side, and the controls give us the ability of moving slow motion controls, as well as setting speeds, parking, and so forth. Pointing model, the first part of a pointing model is basically you scan the fields. So you specify the density of fields you want to have. Do I want to do a 30 field pointing model or a 200 one? And then the second phase is where you take that data and you actually compute the pointing model. As I mentioned, you can do periodic error analysis. You can do polar alignment. The King method, excuse me, is what I use down in Chile, and it's really amazing. You basically just take an image of a star somewhere near the pole, and just wait a while, then take another image, and it will tell you what you should do next. And you just go through a couple of iterations, and I found that worked quite well. A drift method is available as well if you prefer. And finding the telescope position is very handy because inevitably stuff happens, and you need to kind of get the telescope centered up occasionally. And of course, there's a link for astrometry.net. If you don't have a clue where your telescope's pointing, you don't know what the focal length is, this is the tool to use, because it's quite amazing. Automatic observations we talked about, and the object list as well. So I think we've covered pretty much all the high points or the major components in Prism. I don't know if there are any other questions.
A couple of questions, comments coming in. What does ACP? I think this was in response to a specific thing you said. What does ACP do in acquisition that your system does not do yet? Also, did I hear that it will not do a flip, or was that just in a particular mode, like sequential mode?
Yeah, if you've just set it up to take a sequence of 10 images, it will not automatically do the flip. It will do the flip if you've set it up in automatic mode, where you're basically telling it, go do this kind of, go hit these targets, and you take care of the flip automatically for me. So that's the choice that you have. ACP is a different kind of program, because in order to run ACP, you have to have Maxim as well. So you're talking about a much more costly investment, because I think ACP, if I remember correctly, starts somewhere on the order of $900 or something. It has a scheduler in it which is a little bit more sophisticated than what we have, in the sense that it's a multi-day kind of a scheduler. So you say, gee, I want to get 50 images of this galaxy, and I want these filters and so forth, and it will work on a multi-day basis to do that, whereas we just take the approach of set up what you want to do for tonight, and it'll go do it for you. Down the road, we'll probably add that kind of a scheduler capability, but that's down the road for us. And you can see it's acquiring that new image and downloading it right now, and it's writing it. It's slow to write. The reason it's slow, two reasons. One, the computer down in Chile is incredibly feeble because it's run on solar power. So it's a 4-core Intel processor. And we're also writing out to Dropbox. All the images I take down there get dumped into Dropbox and automatically get uploaded to my other computers back home here. So if you run to a regular file, it goes much faster, but Dropbox seems to take a little bit longer because of the special stuff going on there.
Very cool. And I'll ask a few of my questions. First of all, it must be big, heavily used in Europe, because as soon as I posted the program, we got a lot of friends requests, or whatever Google calls them, from a lot of European people. So you said it started over there?
That's right. It started about 20 years ago. So back in the mid-1990s, Cyril Cavadori, who's the creator of this package, created the first version and continued to add to it. And the evolution really was driven in many cases by professional observatories. So this program, Prism, is used by the European Southern Observatory and a number of other observatories around the world to do a variety of different tasks. They particularly like the scripting capability. They like the other tools that are built into it. And so it evolved over time. But the problem was that when you got to version 9, which was the previous version, it had so many different things in there that navigating it was just, well, it was more than I wanted to do. And so that's why we created version 10, which basically streamlined it, left the important stuff in and all the cool stuff in, but got rid of some of the more exotic stuff. That exotic stuff is all there and will be in the advanced version. So if you want to be able to characterize your CCD chip as using a radioactive source, it's in the advanced version. But it's not something that Bob is likely to be doing anytime soon. So that was the trade-off that we made there in terms of getting something that was much more user-friendly.
Gotcha. It definitely seems user-friendly. It seems like a very cool program. I want to remind everyone, all the viewers out there, type your questions into Q&A because we are coming up on an hour. So I want to make sure everyone gets their questions in now. Any questions from within the room? And you guys are welcome to turn your mics on. Oh yeah, how guiding? What, Bob? What about guiding? Is guiding built in?
Yeah, guiding is built in, and I think I showed you the capability. Let's see. Let me just move the screen around a little bit here. The 6303, for example, has a guiding chip built into it, and you have the ability of setting up the guiding parameters on it. It's real simple. You basically go through a calibrate type step. Once you do the initial calibration, you can then have it find the guide star automatically, or you can select a guide star, and away it goes. It gives you a complete report as it guides. One of the cool things it does is it gives you your X and Y positions, your errors, but it also gives you your flux. So you know exactly the strength of that guide star. So if you've got some high cloud that's passing through, you can see that fluctuation occur, and it will stop and then resume as well. So it's a reasonably sophisticated guider. So guiding is it's real easy. As I said, I use this ST402 with an off-axis guider and never had a problem with finding a guide star or successfully calibrating.
It can use either video-based guide cameras or...
Yeah, you can. Let me just flip up here and show you that we have, under cameras, we have all the normal cameras, plus we have direct show. So if you've got an imaging source or a Skyris, which I do, or the ASI type cameras, you can use that for guiding, as well as, of course, you can use it to capture planetary data as well.
Mm.
Tell me about the arrangements for releasing it. It's not released yet. What's happening? Tell me about it.
It's being released. We released it officially at the AIC show in California, and it's being downloaded a lot by folks who are taking advantage of the 45-day free trial. So it will be for sale. We expect that'll occur this week. And you'll see a note up on our website, and we'll send out an email to all the people who've downloaded to let them know that they can now purchase it.
It's not in a beta or anything, though.
No. This has been in beta since June, July, I guess, when the first beta version came out.
You were at NEAC at NEAC.
That's right, exactly.
Yeah, right.
Exactly.
I first met you back there, and then I saw you again at AIC.
Yeah.
So will the 45-day free trial continue even after it goes up for sale and everything?
Absolutely. No, we want people to try it first. Because it's a software product, it's not something we can give your money back on. So we want you to try it, be happy with it, and only then purchase it. So
what release levels do you contemplate for it? A beginner, a DSLR, what?
The three levels that you'll see on our website are basically a DSLR version that'll be coming out next year, the Pro version, which is the one you see here, and then the advanced version, which has all the other goodies thrown in there, including the fully automated simultaneous imaging capability. So those are sort of the three levels that we'll be doing. We do not plan on charging for maintenance fees. Basically, our attitude is we don't think you should really have to pay for us to fix our bugs if there are bugs in there. We would expect you to pay for the next major release if you're interested, but you can always just stick with the release you're on.
Hamza is asking which platforms it'll operate on.
Right now, excuse me, it operates on Windows platform 7, 8, 10. You can run it on XP, but we don't support the XP platform anymore. So if you have problems with it, we'll offer advice, but we really can't guarantee that it's going to operate perfectly on an XP platform. But I know a lot of people are still using it on XP.
And it's not going to the Mac and some of the other ones.
The interesting thing is that we have the ability of putting it on a Mac quite easily. The real limitation is the hardware control. Because all the hardware control, the ASCOM stuff, is really all written for Windows and using some fairly unique Windows technology, we could bring out a Mac version, and we may choose to, that would provide processing capability and do everything else except control your hardware.
That wouldn't do us much good, would it?
I don't think there's a big demand, so it's a cool thing to have for Mac users. We also could do the same thing for Apple iOS and for Android as well.
How's the periodic error analysis train PEC?
Periodic error analysis. Let's see if I can. Where are we here? Analysis. Oh, that's under observatory. Sorry. Okay. Telescope tools. Basically, it's a pretty. Oops. Yeah. It doesn't really want me to do that. Let me just tell you that it's a fairly simple system where you record a number of cycles of the worm, and it does an analysis, and it does a frequency analysis on it, so it tells you the high orders and low orders, and it will and then will compute basically the appropriate adjustments. So it's reasonably sophisticated. It's not as good as some of the totally integrated. So, for example, I have an S-Big Paramount in my backyard, and for that, it's a totally integrated kind of a process where it will create the actual data set to go into the Paramount. If you have a Paramount, you're probably best to stick with that because of the proprietary nature of Paramount. If you have an ASCOM compatible drive, then we can deal with that much more effectively.
What equipment are you using at for this image here?
For this image here, this is basically taken with a 14.5-inch Newtonian. It's an F4 system with a teleview corrector on it, STL 6303 camera, and it's all riding on something called a Pangea Astro direct drive mount, which is capable of handling about 220 pounds of equipment on it. And because it's a direct drive mount with encoders, there's no real need to guide it. So that's the system that's running right now.
Interesting. A newt. I don't know. I'd love to get a big newt myself. I think they're really good systems. What do you think about it in general? I'm sorry for moving on to a unrelated question to that, but
No, it's a good question. The down there in Chile, there's 15 observatories in this particular complex that Alan Maury runs, and he's a great believer in Newtonians. He's told me that this system is probably the first or second best optical system he has on the complex from a point of view of image quality, as compared to some of the more expensive catadioptic type systems. There's a lot to be said for Newtonian. There was a really good article that was in Sky and Telescope back, maybe 6 months ago, where they talked about the Teleview big corrector, coma corrector, and they said how they could put one of those on a pretty simple Newtonian designed device and get some amazing astrographic results. And that's been my experience as well. It gives you the best bang for the buck and gives you wide field, which you really can't get with some. PlaneWave does a great job on scopes, but they're longer focal length, and so you're not going to cover nearly as much field of view. So it really depends on what you're looking for. But if you're looking for an inexpensive Newtonian, I'd certainly look at the Skywatcher stuff with their carbon fiber tubes. Great bang for the buck, and from what I've heard, reasonably well engineered.
Yep, and a lot of the people here know I've been waiting for Astro to release their Newt. It's made overseas, but it looks like an interesting product coming out.
I've seen those as well, and certainly I think that looks very promising. The other thing is from a camera point of view, the STL series cameras you cannot beat for value. I've seen some STL 11,000s going for around $3,000 on Astromart, and they are just a steal because they give you tremendous field coverage, great sensitivity, and as long as you've got a scope and a mount that can handle them, they're just great value.
Yes, I've seen a few of them as well. The problem is the filters, but
what, the limitation of only 5?
Oh no, just the cost of the filters. You could get the camera for a really nice price.
Yeah, but what you want to do is basically the cameras I bought, these 2 STLs I bought, both of them came with filters. So if you just wait for them to pop up, the filters basically they're thrown into the deal. So they're you get a real great value on those, and you can even buy a set of filters. I picked up for one of the STLs. At one point, I remember it was like $300 or $400. I got a set of those filters. So unless you're really looking for the exotic, 3 nanometer hydrogen alpha stuff from Astrodon, you can get some pretty nice stuff for not a lot of dollars.
Yeah, a lot of us. Well, I don't have the Astrodons yet, but a lot of us can't resist them.
Yeah. Well, it's true, and some of these filters down there are Astrodon as well. He makes a great product.
Yep. Well, thank you. It looks like a great piece of software. It looks like it really does everything. The automation where it kind of does your session planning for you. That's really powerful.
Yeah, it has that heuristic built into it, so it's smart enough to know that let's shoot the objects that are nice and high in the sky as opposed to the objects that are, you may have put that object in first, but if it's down low near the horizon, why on earth would we want to shoot that? So there's some smarts built into it, as well as the ability to really tell it exactly what you want it to do, which makes it quite a powerful system.
Very, very cool. So we've gone a little bit over an hour, so I don't want to drag this on that much longer. Is there anything else, Bob, you had that you wanted to cover?
No, I think we've done a pretty good job of covering the highlights and a lot of the capabilities. I would encourage people who are interested, just go to the website prismamerica.com and take a peek and download it if you're interested, and away you go.
Thank you very much. Yeah, there's a link to the website in the description of this event, so you can click it right there, or I don't know, you guys know how to Google stuff, so Prism America. Thanks again for coming. Next week, Innovations Foresight, Dr. Gaston Bodat, I believe is the pronunciation. He's going to go over Starlock and the ONAG, On-Axis Guider, 2 pretty cool pieces of, well, one piece of software, one piece of hardware. But again, Bob, thank you for coming by, and guys out there, we will see you next week.
Okay, appreciate it. Thanks, guys. Take